Last week we started off, walking us through these architecture, and of course, I mentioned to us that it's basically a microservice application called the Online Boutique, which was developed and made public by Google, basically to test the deployment on EKS, to test it with services like Istio and some other platforms as well. Now, the goal of this project, again, just to give us a little reminder, is that the code has been made public, so which means it's available to us and we can use it. And also, the Kubernetes manifest file actually is available within the repository, so which means we can actually just take the Kubernetes manifest file and then deploy this application directly into our Kubernetes cluster without bothering about, building the application, building the image ourselves, and then, pushing that to our own container registry, and then pulling from our own container registry into Kubernetes cluster. Now, the goal of this hands-on project is to, take the source code, build a Docker image from it, push it to our GitLab container registry, and then deploy the image that we have built into our own, Kubernetes cluster. And in this case, we're going to be leveraging EKS. So that's the goal of, this hands-on project. So in the previous video, we, basically looked at how we, talked about the architecture. All right. And I told us that we're going to have to create about 11 GitLab projects for each of the microservice application. Now, I understand that when it comes to GitLab and repositories and all those kind of things, there are different approaches that you can actually take. One of which is basically using what you would call a monorepo, which means instead of creating 11 projects for each of the services, we can actually create a single project and then create a folder for each of these microservice applications. That would also work because that means it's going to be a monorepo and we're going to have a single CI/CD pipeline, for all of these things. And then we can use things like rules, we can use things like only, except, and all those kind of things to basically determine what should be built and what should not be built. But I just thought about it to say, okay, let's do something elaborate, right? Let's do something that relates to a polyrepo where you have different repositories for the different, aspect of your application that you're trying to build. And then let's see how that works. And then, of course, let's see what we're able to learn from it. Of course, there were a lot of mistakes that we're going to make, but of course, making those mistakes will make us better, because by making those mistakes, we'll learn how to do things better and, of course, in a different way and all those kind of things. So we're going to be leveraging this 11, GitLab project for each of the microservice application, like we can see on the screen. Now, we already have our GitLab runner set up in the last video. And then we also have our OIDC set up as well. The last pipeline we ran was basically to set up our OIDC because we do not want to leverage access key and secret key. And as a matter of fact, as soon as we set up our OIDC in the last video, we basically deleted our access key and secret key because we're not going to be needing it anymore. Because now GitLab can basically obtain temporary credentials from AWS to run our jobs and to deploy our resources on AWS, which is a more secure approach. Okay, so already we have our GitLab ARN. The role ARN has been generated, which we stored already in the variable section. And of course, for subsequent, project that would need that ARN, we're going to make it available, all right, in the CI/CD variable of those projects. So now, in this video, what is it that we want to achieve today? What are we doing in this video? Now, already we've seen this architecture over and over again. So what we want to do now is I want to take you through how you would write your GitLab pipeline to build each of these, all right, microservice application. Now, I told us already that when you go into the repo, the Kubernetes manifest file already exists. You don't have to do anything. You can just take it like that and then deploy it to your environment and everything works. But, what's fun is there in that, right? We can actually make it more, fun for us by creating this project, creating the pipeline, building the image ourselves, pushing it into our own repository, and it makes it more fun and of course engaging, and of course we learn a lot from that. Now, if you look at what we have here, in the repository again. The source code is already here, but the only thing that they didn't give us is basically the pipeline configuration. And of course, we are using the GitLab CI/CD pipeline, right? So they didn't give us the pipeline, because if you click here to the .github, I mean, of course, it gives you, some workflows and some Terraform and all that, but we don't have any GitLab CI pipeline right here. The only thing we have is the source folder that contains the source code for all of the applications. And of course, the good thing again that they've done for us is that for each of the source code applications, they already have the Docker file. So they've given us the Docker file. So we don't have to bother about creating Docker file for each of these microservice application. But what we do need to do is that we need to still write a pipeline that can take this Docker file, build an image from it, and then push that into a container registry. But beyond just building the image, we also want to build the application locally, do some testing, all right? Push the code, and then you do some SonarQube code analysis as well before we eventually build the image and then push that into our container registry. And of course, that should also trigger the Helm, repository that we're going to be creating as well. All right. So that's what we want to do. So we're going to be building the pipeline, from scratch. And then I'm going to walk you through how, each aspect of the pipeline, the different jobs that we're going to have in the pipeline, what they do, what the difference is, and of course, what we need, all right, to do differently. And of course, whatever error we get, we fix it. And of course, we learn by doing so. Now that we need to create a project for each of the microservice application. Okay, so when we go here to the README again, we can see that we have the front end, which is written in Go language. We have the cat service written in C#. We have the product catalog written in Go. Of course, we have, different languages. So, which means we're going to be dealing with 5 different programming languages. And one thing you must understand also is that each programming language is unique, all right? And then that means our pipeline is not going to be the same. Okay? So, which means the way we are going to build a Go application and test it, and of course, publish it into container registry and all those kind of things, it's going to be different from how you're going to deal with a Node.js application. And of course, the same thing applies to Java, the same thing applies to Python, and the same thing obviously will apply to our C#, which is Microsoft.NET. Okay, so we're going to be looking at the different pipeline for these different programming languages, what applies, what works, and what does not work, and we are going to also be leveraging the documentation, okay, to help us understand what we need and how to get the things that we need to run our pipeline successfully. Now, in the last video, I did mention that as much as we have AI to our rescue in this day and age, I advise, which is, just my own opinion, that as much as AI is there to help us, is there to guide us, is there to help us generate, as much code as we want to generate as possible, I still strongly believe that when you're building anything, when you're doing anything, DevOps, cloud and all, the documentation of the platform provider or the tool provider should be your source of truth. Okay, now AI can be leveraged as an explainer, or basically, if there's something you're reading in that documentation that you do not explain, you can actually just ask AI a question to say, okay, can you give me an explanation about this line and this line? But I still strongly believe that the documentation provided to us by each of these providers, each of this platform, each of these tools should be the source of truth, which means before you do anything AI, try as much as possible to go through the documentation for the tool, the platform that you want to use, to understand the structure, to understand the intent, to understand the commands and the code that you need to build your application or to leverage whatever it is you want to leverage before you go into AI. Don't just rush to AI to say, AI generates this and this for me. No, go through the documentation, understand the requirement from the documentation, know or the commands and what is expected. And then if something now seems fuzzy, right from there, you can now, go to AI and say, okay, I'm reading something about this and this on this particular platform and all, but I'm getting a bit confused. Can you please explain to me what this line means, what that line means? And then, of course, it basically will provide you some clarity, and then you can go to the documentation to fact check, what AI has actually given you. Okay, so I'm going to be walking us through the documentation, look at, where we can get all the things that we used in this project or where we can get them from, and, basically just read a few of these documentation. All right. So now let's take a look at, of course, the first thing we want to do is to go to our, and of course, what we created in the last video, the OIDC, we can actually verify that from here. So already here, we can see that we have one identity provider, which was created, which is the gitlab.com. And then of course, if I go to my roles, I should see, all right, my role created as well. So if I click on this one, I can see the role. And of course, I can see the permission policy that I attached, all right, to that role. And then of course, I can see the trust relationship as well. So we can see that this is a very neat approach to creating your OIDC using Terraform. And the beauty of using Terraform is that if I need to update, my project path tomorrow, all I need to do is just to go to my Terraform code, put in the new path that I want there, run my Terraform configuration again, and then it basically would update, all right, my trust relationship. And if I want to remove anything, of course, I just basically update that in Terraform, and that makes it very easy, all right, for us. Okay. So we have that figured out. Now, the next thing we want to do, of course, is that we need to create a project. So how do you create a project in GitLab? For those who do not know. Now, here you have the plus sign. So you can click on the plus sign, and then you come here to say new project. All right, and then it gives you this page, and of course you click on create a blank project, and then here you basically put your project name. So the project name can be, let's say we're dealing with a front end, all right, application for now. So I can say front end, for example. Okay, that might be the project name. And then of course, this can be the project slug. Okay, and then the namespace would be my personal namespace. Remember, in the last video, SonarQube was talking about your personal project using personal access token and all. And so this is not going to be under any group, because I don't want to put them under any group, because if you put your project under a group, there are certain restrictions. If you don't have the GitLab Ultimate, subscription, all right, there are certain restrictions. There are things you will not be able to achieve. There are things you will not be able to do if you're using groups in GitLab. So if you want to use group in GitLab, then it is advised that you have the Ultimate subscription, or something higher, maybe the enterprise version and all of those kind of things. But the free version that we are using, right, will not allow us some flexibility when we're using groups. Okay, so I'm just going to put that in my personal namespace, and then of course I can make it private. Basically, it shouldn't be visible, and then of course I don't have to initialize a README, and then I can create a project. Now, when you create a project, as with any Git repository or GitLab project that you create, it gives you these instructions as to how you can connect to that repository and push into that repository. And of course, I've done all of that already, so I don't have to bore us with that. So now, the first thing we have here, let's look at the front end, all right, application. So let's see, it's written in Go language. Let's take a look at what the, pipeline is going to look like. Okay, and then we go to CAT service, we look at what the pipeline is going to look like. We go to currency, which is Node.js. We basically just look at the 5 programming languages and examine what their GitLab pipeline already looks like, so that we have an understanding of the build process and those kinds of things. Okay, so let's go with the front end. So now here I have the OIL opened up already. So if I come here now, this is the code, all right, the source code obtained from, all right, the Google Cloud GitHub repository. Okay, this is where the code came from. And of course, this is the CI pipeline that we are going to be using. So now I'm going to give us a detailed understanding of what is here, because I don't just want to build the image and then just go, because I want us to understand how you can build image for different programming languages. And that is why this project interests me a lot, because we're dealing with 5 different programming languages here. So it's not just a single programming language, we're dealing with different languages. And of course, the pipeline is going to be different one from another. Okay, so let's look at what we have. Now, again, if this is your first time, coming across GitLab CI/CD, I would put a link, to my GitLab 0 to Hero series in the description. You can do well to watch the entire series. It gives you a very good understanding of the entire, GitLab CI/CD, what you need to know to get started, everything about polyrepo, monorepo, container registry, all those kind of things, because this project is not a beginner project. It basically assumes that you have an understanding already. Okay. Now, this is a pipeline for a Go, all right, project, a Go programming language. Now, here we have some variables that have been defined globally. We have the Go version defined globally. We have the Sonar user home defined globally. And of course, we have the service name defined globally. So because we're dealing with the front end microservice application. Now here we have about 7 stages. We have the build, we have the test, we have the security, we have the sonar, we have package, update Helm, and deploy pipeline. So that is 7 stages that we have here. Now, after the stages, we have what you would call a YAML anchor in GitLab. Now, in GitLab CI, you use a YAML anchor basically to define, certain aspect of the job that the other jobs will leverage, which means these things are not things that you want to repeat for every job. You basically would declare them at the global level, and then each of the jobs can actually use what you have declared without you repeating the same thing over and over again. Now here, what we have declared here is basically a cache. All right, a cache. Now in GitLab, there's a difference between a cache and an artifact, but the basic difference between the two of them is that a cache is something that persists beyond the life of the immediate pipeline. Okay, which means when you have a cache in your pipeline, other pipelines can actually use that cache if the key matches. All right, but an artifact is basically for the current pipeline, and the purpose of an artifact is to pass down, some output that you've generated down to the, downstream jobs, so that they can basically use that, all right, to run their job. But a cache is something that would persist beyond the current pipeline. Is that okay? So that's the basic difference between the two. But of course, if you go through my GitLab 0 to Hero series, you would find a better understanding of that right there. So here, we are basically caching, a particular path that, Go would store its module, packages, dependencies, and those kind of things into, so that other stages can basically leverage that, so that they won't have to recreate those dependencies all over again. And the purpose of that is simple. It's basically to ensure that our pipeline is faster, all right, and then doesn't, have to repeat the dependencies and all that have been downloaded, all right, already. So that's the purpose of, having this cache key. And of course, we're using a YAML anchor. The YAML anchor basically will help us to make sure that this job, with the purpose of the dots that we have here, it basically ensures that that job is what is an hidden job. It doesn't show up in our pipeline because it is hidden. So here we have the build phase. Now, in the build phase, we have the stage, the build stage, and then of course we have the image that we want to use to build, that stage, and then we have the anchor, and then we have the before script. So one of the things we're installing here is the Git, all right, tool that we're installing into that image. And the image we're using here is the Golang 1.23.4, and of course you can get that image from when you go to your Docker registry. Let me see, did I have that open up? All right, so here in your Docker registry, when you go to the Docker Hub registry, you can find your Golang, all right, image from there, and then basically this is where we're getting the image, all right, from. So our pipeline is going to pull the image from here and then use that to run our job. And then, of course, we have the Go mode download and then Go build download. Now, where do we get this command from? Of course, like I mentioned earlier, we have to go through the documentation to basically know where these commands, all right, come from. So if you go through the documentation, you have, all right, from here, for example, you have the Go package, all right, manager, where you can get some packages from. For example, you can see the usage here. All right, you can see Go build, Go clean, Go generate, Go mode, and all those kind of things. And for the Go mode download, we can see it from here as well. All right, which is basically to download the modules and the packages and the dependencies that the Go language requires, for that application to run and to function as expected. Is that okay? So this is the page where you can get all those dependencies from, and of course it provides you with an understanding of how to use, all right, each of these commands and all. Okay, if you go through this, I mean, it's a very long list, so we can't go through everything, because if we want to go through everything, we're not going to leave here today. Okay, but I just needed to show you that whatever it is that you need to run your job exists in the documentation. All you need to do is to basically go through the documentation, understand what the programming language, requires, the requirements and all, and then you're good, all right, to go. So that's where we got that from. And of course, it's going to generate an artifact for us. So we have go build -o and then front end dot. The dot basically should refer to the current working directory, all right, and then -o front end. So that front end is basically what we want to cache, all right, as an artifact, okay? And of course, if you go over to the Go build, you're going to see a lot of, you can see the O, the -o basically it means an output. So we have -o, and then the output is front end. The dot is basically the current working, all right, directory. So there's a lot of things that you need to, I mean, if you go through documentation, you uncover a lot of other things. And then the next thing here is to do a test. Now, usually every application that is developed by your developers will usually have, a test. And the purpose of that test is basically to, test some functionality of your application, right? That's the purpose of the test, okay? To test the functionality, to see if some things are working as. So ideally, your application will contain some tests to test the functionality. It can be unit test, it can be functionality test, and whatever test that your developers have written and all that. Now, let me just say one thing here. Now, when you're building a pipeline to run your applications and all, as a DevOps engineer, you need to work hand in hand with your developers, right? I mean, they are the one who have, come up with the application code and all that. So you are going to be working together with them to know the Golang version to use, to know the commands that you're going to need to insert into the pipeline and all those kind of things. So these are not things that you just sit down and just decide for, and then just use a particular version. No, you will be working with your developers to understand the language version they've used, what are the commands you need to put into the pipeline to execute. And of course, you're going to consult the documentation to know what will work and what will not work in the pipeline, all right? So these are not things that you just come up with, by yourself, okay? And then, of course, you have the test phase, which basically should run some tests. So we have the command called go test, which we can use to test the applications if there exists, any kind of test within the code. And then, of course, one thing here that you need to also note is that here we have some rules, which means this particular stage is going to run, if the pipeline source is a merge request event, which means when we push it into a feature branch, and then we create a merge request, maybe to the main branch. Now, before the code is merged into the main branch, of course, it is expected that these phases will run. All right, so you have the build phase, you have the test phase, all of these will run, if the pipeline source is merge request event, which means if you push directly into the main branch, then these phases will not run. And of course, ideally, it's not advised that you push into the main branch directly. You should have a feature branch where you test things, and then if the merge request succeeds, then you can now push into, all right, the main branch. That is the ideal situation. Now, while I was working on these and researching and then trying to put all of these things together, I also discovered that, for different programming languages that we have, they also have, vulnerability scanning tool that you can actually use out of the box. Okay, now I know for some of us, we're familiar with SonarQube to perform some static analysis and all, but each of these programming languages also, they have their own inbuilt packages that can help you to perform static analysis on your codes and the dependencies as well. And one of such that I found for Go is what you call the Go vet. All right, Go vet. And of course, you can find that here also in the documentation. So here is the documentation for GoVet, and of course you can see that is something you can search for in the Go, all right, package repository. Okay, now the purpose of the GoVet, it says GoVet examines Go source code and reports suspicious construct such as printf calls whose argument do not align with the format string. Vet uses heuristics that do not guarantee or report genuine problems, but it can find errors not caught by the compiler. And it says vet is normally invoked through the Go command. This command vets the package in the current directory, all right, and then whereas this one vets the package whose path is provided. So which means if you just do go vet, it basically would scan the code in the current directory, and of course if there's maybe a particular folder or directory you want to scan, you can basically pass that as an argument, all right, as well. And that is what we have used here. So go vet echo, but then your go vet command generates a report in JSON. Now when you are dealing with GitLab CI, let's say, for example, you're using the GitLab Ultimate and then you want to publish your security scan report, and then you want that to be visible in your merge request and in the GitLab security dashboard and, compliance dashboard or vulnerability management dashboard, then you might have to restructure the JSON that GoVet gives you, all right, to match with the construct, all right, that the GitLab SAST report actually requires, because they are not of the same construct. So the echo command you see here, just a placeholder, just to mimic, all right, that particular report, all right, so that we can publish that into GitLab SAST, dashboard. But of course, unfortunately, we can't view that because we don't have the ultimate, all right, subscription. But if you go over here and you scroll down, you will see here that one of the core flags is -JSON, which basically says here, it says emit analysis, diagnostics, and error in JSON format. But that JSON format, like I said, is not the same as what, your GitLab SAST report, all right, requires. So you have to still run some kind of, you have to come up with a code that can convert the JSON, all right, output that GoVet gives you, right, to match what, all right, GitLab expects. Is that okay? And so that is why we have these echo command, just to mimic, all right, that particular stuff right there. And of course, we have the active file, we have the report, and then we have SAST. The purpose of the report as SAST here is basically to make sure that that report is visible in the merge request event. And of course, it can be, you can see whatever errors that exist in the report and whatever it is that you need, all right, to correct. And of course, we have a part here, which basically means we can also download that report, and then our developers can actually, all right, virtualize that. And you can see here that that is also, will also run, all right, with a merge request event. And then here we have the Sonar stage. So we are also going to be using Sonar to scan our code and all those kind of things. So now this command that we have here as well, where did we get, all right, these things from? So because I really want to take us through, how we got all of these things, so that you basically understand, that documentation still exists, so that we can leverage it to understand the tools and the platforms that we are using. All right. So now, if you go here to SonarQube, let me just refresh this page. All right. Now, if you go to SonarQube, and then let's say, for example, of course, you can see all the report that I have, but let me show you how you can go about it. So if you come here to new and click on Analyze New Project. Now, because of the token that I showed us, in the previous video, you can see that here, it basically will list out all the GitLab projects that I have in my account, all right, for me. And then it basically would, allow me to pick any one of them, all right, that I want to analyze. Okay. So if I click on this one, and then I will click on setup, and then of course I'm going to click on previous version, and then I will say create project. Now, once I create that project, I can come right here. It's going to give me this page, and then I'll come here and say with GitLab pipeline. So choose your analysis method. So I'm going to click this one. Now here, for this particular project, is going to provide me the Sonar token, all right, and of course the Sonar token as the name of the variable, and then of course the token itself. Okay, so what I need to do now is I can go to my GitLab, platform. Say for example, I can come here, go to security, for example. Okay, so let me just go back to that repo. EKS infra, or since we're dealing with front end, let me just open the front end stuff. So I'm going to come here to front end. Okay, and then I'll come right here to settings. I'm going to CI/CD. All right, and then I'm going to go to variable, and then right here you will see that I have the Sonar token. Okay, and that Sonar token is basically what I have here. So basically, I'm following the instruction that SonarQube has given us. Okay, so you copy the name. That's going to be the name of the variable, and then this is going to be the value of the variable. So you copy that, and then of course the host URL, you also copy that as well, and then you basically follow the instructions that you have right here. Now, the interesting thing here also is that SonarQube also gives you, all right, the GitLab CI, file on how to basically scan your code, all right, with SonarQube. So here, it gives us, different options. So basically, whichever programming language you're using, you can find an example right here. So there's an example for JavaScript and TypeScript, Maven, Radio.NET, Python, C++, Flutter, Dart, and others, which is Go. So for others, we're going to click on this one, since we're dealing with the Go, all right, programming language. And then here we can see all the variables. So we have the Sonar user home. You can tell that this is where we got, all right, these Sonar user home from. So you can see that it's not as if we just came up with it or just AI just generated things for us. We basically leveraged what we have in the documentation. Okay, so Sonar home, you put that there. Git depth, I mean, if you want to use that. Then SonarCloud check, of course, we're using this image right here. Now, if you look at what I have here, now you can see that I'm using that Sonar source, Sonar scanner CLI, basically what was provided here. And the entry point, I didn't put any entry point here, okay, because I mean, when I tested it, I felt that was not going to be necessary. So I didn't put an entry point right there. And then you can see the cache as well. So the key name, the path, all right, is basically leveraging that, all right, as well. Okay, so now, another thing also here is basically say sonar-scanner. But one thing that you need to note is that now there's going to be a sonar project properties that you can actually create in the root directory of your project. But I don't think that is necessary. So what I did instead was to basically put all of those things, as variables. So for example, the project key, I basically just put the name of the project key right here. Organization, I store that in my variables. So if you come here you can see the Sonar organization right here, okay? And then the URL, of course, that's also a variable here, host URL. And then the Sonar token, of course, that's going to be a variable as well in my project repository. And then the Sonar sources, basically the current directory is what we want to scan. And these are files and folders that I want to exclude from scanning. And then, of course, this should run, all right, if it's a merge request event and if the commit branch is also main. So which means this particular stage is going to run if it's a merge request event and if it is also, all right, committed into main. So either, any of it, right, it will run this particular stage. Now, after that, you now have the Docker phase because we've tested, we've checked all those things and everything is fine. So now we need to build this image, all right, and push that into our GitLab, all right, container registry. So we have the package stage, which basically is to build the Docker image. Now here, we need to update the tags, all right, that we have here, because remember I told you in the last video that, of course, I've exhausted my compute minute for the month, so I have to use my own runner instead of using, all right, the runner available to me, all right, that GitLab has provided us by default, which is the shared runners. So I need to update, the tags here. But before then, let me just walk you through what we have right here. So here we have the package. And then we have the stage. The stage is packaged. The image is Docker 28.33, which is about the latest Docker image that we have in Docker Hub. And then, of course, here we say it needs Sonar, which means we want the stage to be passed before this, the image is actually packaged and the image is built. Okay. Of course, we can also say that it depends on security as well, which means these two stages will have to pass before, all right, this Docker image would run. All right. We can actually do that. So I can come here and say, this needs security, all right, and it also needs the Sonar stage, right? I can add those two, which means it's going to depend on those two jobs. So which means if the two jobs fail, then the Docker, all right, build is not going to happen, all right, at all. Okay, now here we are going to need what you call a services, right? Because what we are doing is that we are building a Docker image inside a Docker container. So we need, a services for that. And that service is what you call Docker in Docker, which is actually another image that allows you to run, Docker related stuff inside a Docker image or a Docker container. Okay, so we need that as well. And then, of course, we need this build Docker TLS CI basically to allow that communication to take place securely and all that. And then we have the Docker build kits. Now, why do we need a Docker build kit? Because we are using not the Docker build, we are basically using what you call Docker build X build. Now, Docker build X build has a lot of advantages. Now, with Docker build, you can only build an image, all right, and that image is going to leverage, all right, the architecture of the system that you are building, all right, the image, it's going to leverage the architecture of that system, all right, to build the image. So which means if you're building an image on, let's say, a system that is ARM64, then the image that you're going to generate is going to be what? Of the type ARM64. But one of the advantages of the Docker Build X is that it allows you to build images for different architecture. So you can build an image for ARM64, you can build an image for ARM64, for, whatever architecture you want to build an image for, Docker Build X allows us to do that. And if you want to use that in your pipeline, you need this particular variable, all right, in order to do that. So now the variables that we have here are basically job specific. All right, these variables are what? Job specific, which means these variables are only available within this job. So they are not global variables, okay? And then another importance of the Docker Build X is that it allows you to do what you would call cache inline, all right, and then cache from as well, which means when you build an image and you push that image to an image registry, now if you want to build another image, maybe there's an update and then you need to build an image again. Now, instead of, the image, downloading all the layers and compiling all the layers all over again, BuildX gives you the privilege to fetch the previously pushed image, now leverage some of the layers that is similar to the new image that you're trying to build. So that way, those layers are already cached. Now in the new image, you don't have to create those layers or build those layers again. It basically will leverage what has been cached and then use that to build, all right, the new image. And what that does is that it saves a lot of time. Because it basically will say, okay, this layer has been built already from this previous image, so we don't need to build that again. It basically will use that, and then it saves you a lot of time. And the Docker builders command also allows you to combine Docker build and Docker push command together, which means I don't have to do Docker build and then Docker push again. No, I can basically run that as a single command, all right, as a single command. So that's the reason why we are using the Docker build X build. Okay, now if you look at the before script that we have here, we have the echo CI registry password. Now, one of the things that personally that that makes me have a bias, all right, for GitLab CI is that quite a number of the things that you need in GitLab CI, they have a predefined variable for most of the things that you will need. And for me, that's why I kind of have a bias, all right, for GitLab CI. Of course, GitLab Action is great, other platforms are great, but I just have, that bias, all right, for GitLab, okay? Now here, with GitLab CI, you can see that everything that I've used here are basically predefined variables. And that is because I am leveraging the GitLab container registry. Okay, I'm leveraging the GitLab container registry. So for this particular application that I want to build and then push the image to the container registry of GitLab, I don't have to create any CI/CD variable. Like my username, like my password, I can basically leverage the predefined variable that GitLab offers us out of the box. For example, the CI registry password is basically going to generate a password that this particular job needs at runtime. Okay, so if I go here to my predefined variables space, all right, and I try to search for these, you can see that it says CI registry password. It says job only. It says the password to push containers to the GitLab project container registry, only available if the container registry is enabled for the project. This password value is the same as the CI job token and is valid only as long as the job is running. Use CI deploy password for long-lived access to the registry. So, I don't need a long-lived password. So I can basically just use CI registry password, which I can use to push, all right, to my project container registry. And the container registry of my project has been activated already, all right? So I basically just need this predefined variable to do that. So I don't need to put my password anywhere. I don't need to create a variable for that and all that, okay? So that makes it very easy. Now, again, you have the Docker login, because before you can push into any container registry, you have to authenticate. All right. So the Docker login, again, you can see I'm using what? CI registry username, another predefined, all right, variable. So let's see what that is. Now, the CI registry says the username to push containers to the project GitLab container registry, only available if the container registry is enabled for the project. And of course, the container registry is enabled for the project, so I can use CI registry user, all right, and that would basically, use the what will you have here, the username, to push to the project registry at runtime. So I don't have to, hard code anything or create variables again in my CI/CD. And of course, password standard input. I'm passing the password as a standard input so that it's not visible in the job log and all that. And then, of course, I'm pushing to the CI registry. Again, another predefined, all right, variable. Okay. So if I click that, I can see CI registry, and I say it says address of the container registry server formatted as host and port, for example, gitlab.com example, blah, blah, blah. If only available if the container registry is enabled for the GitLab instance. And of course, it is available. All right. So you can see that all through this, stuff, we didn't have to create any variable. We basically leveraged, all right, the predefined variable that GitLab offers us out of the box. Okay. And that's one of the things that I love about GitLab CI/CD. Now here you also have a rule, and the rule here is basically that this particular job is going to execute if the commit branch is made. So this is not going to run, a merge request event and all. But of course, you can also have, you can also scan your Docker images as well. I mean, when you package your images, you can also have another stage that basically will scan that image and do all of those kind of things. I mean, that's what you would do if you're doing a full-fledged, CI, a DevSecOps, all right, pipeline, which is actually a very good practice. Okay, but of course, I just have decided to exclude that, just to make these things easy for us to digest. For the purpose of those who may not have, the advanced knowledge that some of us possess, to make it easy for them to understand what we're doing. Maybe in another video, we'll take a look at, scanning your Docker images as well against vulnerabilities, as we have done for our application code already. Okay, now the next job is to update the M values. Now, which means we're going to have this Helm repository. Now, the purpose of the Helm repository is basically to have our manifest files. Now, again, like I told us, if you look at the project, right, they already have this Kubernetes manifest, right? So all of the microservices application, they already have them here in the YAML format. Okay, if you click on each of them, all right, you will see the deployment and everything. If you come here, but of course, when you come here, what you have here is just image name is add service, and that's not a complete, all right, image name. Okay, so what we want to do now is that we're going to turn this Kubernetes manifest file into a full-fledged, Helm templates, where we're going to convert it into an M template where we have values.yaml and all these other things, so that as we build these images, the values.yaml can be updated with the latest image, registry name, and then the image tag. So from there, it will be easy for us to deploy from the M project to our Kubernetes, all right, cluster. So the purpose of this stage or this job is basically to say, now we've built the image, we've pushed the image to the image registry. So what we want to do now is basically to clone our Helm project, all right, within this pipeline, and then do what you would call a checkout. So if you look how we have the stage, we have the image as Alpine, and then we said it needs the package, which means it needs the Docker stage. Okay, and then the before script here basically says happy k hard, no cache, git. Of course we need YQ and we need git, because we're going to be doing git checkout, we're going to be doing git clone and all this kind of, and then we need YQ because the Helm values file is actually written in YAML. Okay, it's not written in JSON. If it were to be a JSON file, what we're going to need is going to be JQ. But in this case, what we need is YQ, all right, which is basically a YAML kind of, query editor that can allow us to edit a YAML file and then insert values and those kind of things. And of course, we need to specify, when you're doing your git commit and git checkout, git commit and git add, git commit and all those kind of things, you need to specify a username and a password. And then again, GitLab makes it easy for us because we can actually use ci@gitlab.com and then specify that this is a GitLab CI, all right, operation. And the actual script here would basically do a git clone. So basically we're cloning that repository. So that means the M project, we must store the M project URL and then the M token, which means the fact that this project belongs to the same account does not mean that it can automatically clone, all right, that project and then modify its files. No, because that project itself is a private project. It's not a public one. If it were to be a public one now, maybe you can make such, edit and all this kind of thing, but it's a private, all right, project. So which means for the M repo or the Helm project, you need to go to your GitLab. All right, the first thing you need to do here, of course, is to create, all right, a Helm, all right, project. So which means we're going to need a Helm project that will contain, the Kubernetes manifest file and all those kind of things. As you can see here, I have the Kubernetes manifest file here. And then from this manifest file, I generated, all right, what you would call a Helm chart that contains, the values, the YAML, the chart, the YAML, and all those kind of things. And that basically is what we are trying to now modify. So here is the microservice chart. And then you can see the values here. All right, and then you can see the chapter. So these values of YAML is what we're trying to modify. And all of the templates, we have them, all of them. We have all of them right here, okay? But I'm going to be talking us through that as we go on. Now, we already have this Helm project. So what we need to do now is basically for this front-end application, it needs two things. It needs the URL of the Helm project, and then it needs a token that it can use to connect, all right, to the Helm, all right, project. So it needs those two things. So now, in the Helm project, we need to generate, all right, a project token. So under CI/CD, we can come here and then we can come to access token, I believe, all right, and see if we can get a token there. Or let's go look at the CI/CD space, all right, and see where we can get a token from. Okay, let's take a look at that. So we have job token permissions there. I mean, that's not where we need the token. All right. And if we can find any token here, because here we have access token. Now, under the access token, of course, you can actually come here and add a new token and then specify the token name, specify the description, the role, developer, maintainer, or whatever role. And then here, you can basically specify, all right, whether you want them to, what we need is to basically to write the registry or write the repository rather. So write the repository and read the repository. I mean, you can give them those two permissions, because what we want to do is that the front-end project should be able to write, okay, the Helm, should be able to write the Helm project, the right values of the YAML file. That's what we are trying to achieve right here. So you can actually create a project token, okay, but if this project token, if it's not going to work for you, another thing that you can also do, perhaps if you test it and it's not working and all, you can actually come here to preferences as well. Let me just show you another way, and then come here to access token. Now here you're creating more like a global, token and all those kind of things. All right, you're creating that. So you can come here and then create what you call a project token. All right, you can create a project token here. You can create a project token here, and of course you can see that the one I created is actually expiring, right? Token expires in less than 2 weeks, so it's telling me that it's going to be expiring soon. Now, so here I have the scope. So the scope is read repository and write repository. So now the advantage of creating the token at the account level is that it can apply to any of the project that you have. All right, it can apply to any project you have within that environment. Okay, so that's the advantage of creating a project. But of course, you can actually leverage, a project level, all right, access token. Okay, so here we have just read repository and write repository. So that means the front end project is going to be able to modify files inside of the Helm, all right, project. And so what we have here is that we have the git clone. So we're cloning that repository. So we have the Helm repo token, and then we have the M repo, all right, URL, okay? And then we are cloning that into this M repo directory. And so here we have the CD into that M repo, and then microservices-chat, which is the name of the folder that we are interested in. So if you come here to the Helm repo again, you will see here that we have, all right, if you come here, you will see that inside of these projects, we have what you call microservices chat. So by the time it closes, of course, it's going to clone everything. So this folder is what we're interested in. And then, of course, now here, we are also doing something. We're doing git checkout, all right, to a future branch. We're not checking out to the main branch, because we want to be sure that the values.yaml was written correctly before we merge into the main branch. So what we are doing here basically is to check out into the future branch, right? So we're checking out into this particular branch, okay, so that we can monitor and see things for ourselves, all right? So we're checking out into this particular branch. Now, and then here, once we check out into that particular branch, of course, we can make our modifications. So here we have the YQ evaluate and then .services, basically in the YAML file. So if I come in and I come to values of YAML, So I can see here that I have these services, right? Which is also a top level, all right, service, okay, a top level object, okay? So services dot, and then of course the service name. So the service name is a variable, which is what we defined here already. So if you come here, we have the service name as front end because we want the image name for each of the services to be unique, basically using the name of each of the services. So we have that. So the service name dot, all right, image tag. So what that would do for us is basically to come here, services image the tag. So basically, put a tag there for us. Okay, so that service names, the service name should match what we have right here. So the service name for this one, for this first one is actually add service. So it's going to match this particular name. So if it matches this name, now what we want to do now is that we're looking for the image tag. So we're going to be saying, or for the first one, let's go with the first one first. So services, service name. So basically, we're looking for a service that has the name of this service name. So if it is front end, it will match. If it doesn't match, then of course, it's not going to be able to do the update that is necessary. All right. So the service name, and then of course, we're looking at image.repository. So which is this image dot repository, and then that will update the value that we have right there. All right, and then it will update that with this CI registry image / service name, which is something that we'll get from this particular stage, and that's why it is dependent on this stage, all right, to run. And then of course, what we want to edit is values of YAML. So basically, we're pushing that edit or that update into this particular file, values.yaml. And then the next thing is to update the tag as well. So the tag update is going to be using the CI commit short SHA, okay? Because if you look at what we have here, we have two images that we are pushing. We are pushing the one with the latest tag, and then we're also pushing the one with the commit short SHA, all right? So that means the tag is going to take on, the commit short SHA, so which means for every build that we do, all right, it's going to have a different, all right, commit, short SHA, and that's what you have right here. So this one is basically the short version of your commit, all right, number. Is that okay? And then of course that would update the YAML file as well. And then once that is done, we'll basically say git add values YAML, because that's the only file that we've modified. And then we do our normal git commit, all right, and then git push origin, and then the origin here is the future/boutique/helm. So now, by the time you run this is going to, all right, trigger a merge request in the Helm project, right? It's going to trigger a merge request in the Helm project. And so before you merge, you can actually view the changes that has been made. If it's okay, you merge into the main branch, and then the Helm project will execute, all right, and then that would lead to, you now applying the changes into your Kubernetes environment, okay? And then another thing that I want to show us lastly is this trigger that you have in GitLab, which means you can actually trigger, another project in GitLab, right? So here we have the trigger pipeline, we have the stage as deploy pipeline, we need the update envelope because we want to be sure that the values have been updated before we perform any kind of trigger, all right? And then of course the project we want to trigger is the Helm project, and then the branch is, all right, the future boutique-helm, which is the feature branch. We're not triggering the main branch, all right, because the feature branch should be like, where we can test things and be sure that things are okay before we merge into the main branch, and then we run the pipeline normally. So once the M chart has been updated, or the values of YAML has been updated, this right here is going to now trigger, all right, that particular branch, and the strategy means depends, which means this particular front-end job, the pipeline is not going to pass until the downstream, all right, Helm project has succeeded, all right? And then here we says the rules is if we commit into main, which means if this pipeline is committed, merged into the main branch, then it's going to trigger, all right, that, other job, which means the Helm project is not going to be triggered automatically, right? It's going to be triggered by a pipeline. So in this case, the commit, all right, the rules is good for the Helm branch is going to be that it has to be triggered, all right, by a pipeline. So if you come here now, for example, to these, repo, the Helm repo, and you go to the feature branch. And then if you come right here to the CI file, you will see that there are a lot of rules that we have here, which means the first one says if the commit branch is equal, all right, to this. So which means if somebody makes a commit to that branch, which our front end and then other services will do actually, because they're all going to be committing into that particular branch. And the pipeline source is pipeline. Okay, the pipeline source is pipeline, which means it was triggered by another pipeline. Can you see that? It was triggered by another pipeline. Then what should it do? Of course, it should always run. And then we have another one because now we have the main and we have another feature branch. So we have another rule which says if the commit branch equals to main and the pipeline source is a push, which means that push that you see there means that there was a commit or a merge request. All right, there was a merge into the main branch. Then the pipeline should also, all right, be triggered. So that's what the push there means. The push there means, it doesn't mean that you push into the main branch. No, it means that somebody pushed into your feature branch and then from the feature branch, you now merged into your main branch. That is also seen as a push into, all right, the main branch. And then of course, if it doesn't meet all of these things, of course, nothing else should run. That's why you have the when, never. And then, of course, if you look at these that we have here, maybe we just have some examples right here. So we have all these, Helm links just to create some stages and all that. And then we have the deploy phase. So this deploy phase is actually what will now be triggered, of course, but it's still going to be triggered manually anyway. And the trigger is only going to happen on the main branch. So we also have another condition. Now, this condition does not mean it's overriding the workflow rules that we have here. It basically just means that we are saying that this particular job, regardless, should be triggered manually and should only be executed in the main branch, which means this job is not going to be available to the feature branch. We can't deploy from the feature branch. It has to be deployed from the main branch to prevent any unwanted issues and, deployment issues as well. And then we have another branch basically to verify that our pods, the ingress and everything, all right, is working. So now that we have an understanding of the front end pipeline and what we need to build the front end application, which is written in Go, I believe we can now go ahead and push, all right, to the repo and then let the build happen. Okay. And then let's see what we're going to get. Now, another thing that I also want to mention is now that we've done it for front end, it will be easy for us to do for product and for checkouts and then for shipping as well, which are the four, all right, microservice that were developed in the Go programming language. Okay, so we don't have to reinvent the wheel for product, for shipping, and for checkout, and all of that. All right, but let's basically push this into the GitLab repo and then let the GitLab pick it up from there, let it run the pipeline for us, and let's see how far, all right, or how well we did with the pipeline. Now, first things first, I need to bring up my runner because don't forget, I've exhausted my runner for the month, my compute minute for the month. So I need to bring up my runner so that I can actually use that to run the job. Now, another thing here that I need to mention is that this particular GitLab runner was registered under another project, which is the EKS Infra, if I remember correctly. It was registered under this particular project. So that means if I come here to front end, let me open up the front end project. So if I come here to the front end, all right, project, and I come right here to services, CI/CD, and I come here to runners, I would see here that there is a runner here, right, which is of course not available, but I can see that there's another one, which is the one that we, deployed for the EKS infra, right? So if I come here to the EKS infra and I come to the CI/CD and I come to runner, we can see that this runner is actually assigned to this project, all right? But if you come here, we would see that this is under other available runners. So if I want to use this runner for this particular front-end project, then I need to enable it for this project, okay? So I need to click on enable for this project, and then it now becomes available to this project. So this project can actually now use, all right, this runner as is. So a few things we need to do. We need to update jobs to basically leverage that runner. So I'm going to come here, and of course, we're going to say the tags is AWS, and then Docker. All right. Because those are the two tags we have, AWS and Docker. So I'm basically just going to copy the tags, and then I will go to the next job, and of course, paste it there. Go over to the next one, and then put it there so that my GitLab knows that it needs this tag to run the job. All right. So let's put it there. Do the same for this. Okay, we already have one here, so I can remove that. Okay. And then for the update Helm, we need that as well. So I'm going to put that here as also. And then for the trigger pipeline, yeah, we're going to need to specify the tag as well. All right, because we don't have any compute minute left that we can actually, so they have to use, all the jobs have to use our own runners. Okay, so that's the update we need to add in addition to what we've done so far. So now you can see here that I'm actually inside of the feature branch. So if I do git branch -A, I can see that I have two branches. So there's a feature branch and then there's the main branch. So I'm pushing into my feature branch, so that would do its own, stuff and all of that. Of course, I mean, I have to create a merge request event in order to trigger the pipeline. All right. So, but of course, I have to push into this feature branch in order to set that up. So I'm going to say git commit -am since there's nothing new to add, and then I'll basically say, let's just say updating the front end pipeline file, right? And then I'll basically just do git push. Okay, so once I do my git push, of course, it goes into that branch. So I can come back right here, and I can come to my front end. I should see that right now it's asking us to create a merge request, which would ultimately trigger, all right, the build, the pipeline process and all. So I'm going to come and say create merge request. And of course, I'm going to scroll down the assignee. I can assign it to myself, and then delete source branch. I don't want to delete the source branch. And then I'll say create a merge request. So once you say create a merge request, of course, it should set up a pipeline, but then it failed. So let's take a look at why it failed. It says here, job trigger deploy pipeline contains unknown tags, unknown keys, which is tags. Oh, my bad. So, so look at the error that we made, right? So here, this particular trigger job here is actually not a job. It's actually not a job that would run in this, all right, project. The purpose of the trigger job is to actually trigger the pipeline in another job. So that other project is referred to as the downstream project. Okay, so here I don't need this option right here, because the purpose of this particular stage is actually to trigger a downstream project. Okay, it's not a job per se that would run. It's basically to say, okay, I wanted to trigger this project, and then it triggers it, and that project will run. Now, if that project succeeds, then that would return back, a status response to the trigger job, and then the whole front end project will now say, okay, now the project is successful. All right, but the tag here is not needed because this is not an actual job that will run in this particular project. So we really do not need the tags right here. Okay. So let's remove that, and then that's a good way to learn for us. So let's remove that, and then let's push again. Okay. All right, good. So that's the purpose of, that's the reason why we're here. So I'm going to commit that again. So git commit. So I'm just basically going to say removing tags from trigger, all right, job. Okay. And then we push again. So once you push again, now the pipeline should actually, all right, work. And of course, because the merge request, all right, has not been merged, okay, it will trigger the pipeline automatically. And do you see that? So I didn't have to create a new merge request, all right, because there's already a open merge request. So the moment I make another commit, the merge request is still there, right? It's just physically going to start, all right, the pipeline, okay? So we can click on the pipeline. And then, of course, now this stage or this particular project do not need the OIDC, because what we're doing really does not have anything to do with AWS at this stage, all right? And so we don't need the OIDC for this. Everything we're doing here does not need to interact with our AWS environment. So we can see here also that the archive is up to date, which means, there is really nothing to add. It's still the same patch that they're using. And then for the Sonar, let's see what that would give us. So now 3 stages have passed. So the last stage here is the SonarQube stage. All right. So we're still doing everything in the, merge request. So if I come here to my merge request and I click right here, I can see the pipeline, as it's progressing. You can see that. So it's the merge request pipeline. And then, of course, the SAST scan have been generated. But like I said, because we're using the GitLab.com, and of course we don't have the ultimate subscription and all that, we won't be able to see exactly what the SAST report is. We won't be able to see that, okay? But if we had the ultimate subscription and all, we'll be able to expand these and see exactly what the, the report is. But since we don't have that, but it's fine. All right. It's okay. So we just have to, but it's good that we know that something like that, of course, happens. So you can see that the Sonar job has actually passed as well. So we can see that has passed. And then, of course, it has uploaded the report to, you can see all the reports here. So if I go to my Sonar scanner here, and I click on my project, and then I can come here to, let me refresh and see. I should see my front end. So if I come here, all right, the front end, where are you? All right, so this is front end. So if I click on front end, I can see the merge request. So if I click on merge request, I can see it right here. So updating the front end pipeline file, right? So we can click on that. And then, of course, it tells us that, in that field, it didn't meet the condition. Now, it's actually using the default, quality gate, right? But the problem is we can't create our own quality gate because of the version we're using. We're just using the free version, okay? But, but even default one is still failed because security rating required is A, but that means the security for this particular front-end app is E, and of course, it failed. Now, normally, if we were using the paid version of SonarQube, it means that pipeline should actually fail, and we should also see the report. If I go to merge request, for example, all right, if I go to my merge request, and right here, I can see here that even the quality gate failed, right? But because we're using a default quality gate, and we can't create a new one, we can't modify the existing one because of the version of SonarQube that we're using, all right, is to still pass all the same. But if we had access to, create quality gate and then create what you would call a webhook, basically, because normally the pipeline should actually have waited for the report of the quality gate before deciding whether the pipeline would pass or would fail, okay? But obviously, it didn't wait for that, because if you look at the pipeline, if you look at the pipeline, for example, let's look at the pipeline again. I just want us to get this. If you look at the pipeline, if you go to the SonarCloud, all right, it basically just, tells us that the job succeeded, despite the fact that the quality gate failed. All right, and that is because we don't have any configuration between the SonarQube quality gate and the pipeline, right? That should inform the pipeline to wait for the quality gate report in order to ascertain whether the job passed or whether the job failed. Okay, so we don't have that configured, and of course, like I said, that's because we're using the free version. If we really want to test that out, then that means we have to upgrade, and that's about $32 a month. I don't think we're ready, all right, for that. Okay, so you can see here that it actually failed. So the security rating required is A, but it got a security rating of E, which actually is not too good. Okay, so that's another way to look at it. So there's actually what you call a blocker, all right, and of course, if you read through it, it can tell you where the error actually is coming from. So you can see where the error is, all right, what the issue actually is, and of course it tells you what the problem is. It says change this code to not perform redirect based on user control data. HTTP request redirection should not be open to forging attacks, and of course it tells you, all right, the known vulnerability, that relates to. Okay, but like I said, if we had configured our quality gate, it should have just failed, all right, the pipeline, but we don't have that configured, so it still passed all the same. But of course, in a work environment, if you have access to SonarQube paid version and GitLab Ultimate, these are things that you can do to improve, all right, your pipeline as well. Okay. So of course, here we can see the report actually right here. Okay, we can see that report here and tells us the field, the condition, and all of that. So now we can merge. Okay, I hope you get the idea of what we're doing. So you can merge now, and of course, once you merge, so look at that again. We merged and then we got an error. So let's click on it and let's see the error that we have. Okay, so here it says the package job needs security job, or security job does not exist in the pipeline. This might be because they only accept and root keywords to need a job that sometimes does not exist in the pipeline use needs optional. So what do you think is the problem with this? All right, I think I know where the error is coming from. The error is coming from here. All right, so the package job depends on security job and depends on Sonar. Okay, but unfortunately, the security job is a job that runs, all right, if there is a merge request event, all right, which means this job does not exist in, all right, if you're merging to the main branch. Okay, so if you look at this pipeline that has been created now, I didn't even create a pipeline because there's nothing like a security, all right, job. Okay, but the idea here, or what caused the error, actually is that the security job is only triggered or run if the pipeline source is merge request event, which means this pipeline, this job is not going to run if the source is main branch. All right, if the commit branch is main, it's not going to run. And so if we're saying that the package job depends on the security job, it means that that security job should also be executed, all right, in the main, branch as well. So in order to fix that, there are two ways I can go about it. The first one is to come here to say, to add another if. So I can say if, all right, and then you have the commit branch. Okay, you can use this. If the commit branch is equal, all right, to main, then I can actually do this, right? So the same thing that we do here. So I can actually add that. But if I feel that I don't want the security, test job to run in the main branch, since I've done that on merge request event and I think everything is fine, all right, I can actually just do what? I can actually just come right here, and then I can come here and then just remove this. So I basically say, I don't need this, all right? I don't need that. And then another thing I can also do is that, for the Sonar job as well, I can decide and say, the Sonar job, I only want the SonarQube job to run, if it's a merge request event. I don't want it to run again, if I commit or if I merge into the main branch. I mean, that would slow things down. So I can actually come here and just remove this. So that means my SonarQube job is going to run just in the merge request event pipeline. And then if I merge into the main branch, the only jobs that will run will just be to package my Docker image, all right, to build my Docker image, push that into the registry, and update, all right, the Helm repo. That is the only jobs that will run. I mean, these are the other jobs that would run eventually. So which means any security stuff, anything that has to do with security, anything that has to do with, testing and all those things, I want to do all of those things, if it's a merge request event. If it is not a merge request event, I mean, I can, if the merge request event passed, all right, if there are no errors at that point, then if I merge into the main branch, then it can actually go ahead and build the image, update the repo and all that, so that if there's any error at all, I can catch that, if it is a merge request event, I can catch that in the merge request event pipeline and then fix it, run the merge request pipeline again, and then if everything passed at that point, then I know that whatever it is that I'm merging into my main branch is okay, is good to go, and no issues whatsoever. Okay, so let's try this again and let's see what this will give us. So I'm going to come in now and say git commit -am, all right, and I'm going to basically say, all right, allowing Sonar and security job to run only in merge requests event. Okay. And then of course I'll do a push. Now, what this will do also is that, I mean, those jobs will run in the merge request event. And then if they pass, all right, I will need to do them again in the main branch. All right. So I can come right here, go back to front end. Of course, I have to create another, all right, merge request because the other one has been, try to merge that. It didn't work. So it's going to be a new merge request and then create another merge request. So that will trigger, all right, another pipeline. Okay. And of course, I can click here and it's going to do the same thing really. But now another thing that I want us to look at also is that the cache, already we have a cache that we have created. So the pipeline should run faster than, the first time that it ran. Okay. Because we already have a cache that has basically helped us to cache all the dependencies with Golang and all those kind of things. So let's pay attention to the time we have here. So the elapsed time now is 27 seconds. So it's running for 27 seconds now. Let's see how long this will take. I mean, since we already have a cache, all right, so it shouldn't take more time than necessary. Okay, and that's the advantage of having a cache in the first instance. So let's see how long this will take. We can compare that with the first pipeline I ran to basically see, how long it took and if the cache actually is effective as we expect it to be. Okay, so you can see now it says successfully extracted the cache. So that means, all right, I mean, it's not going to have to recreate it again. And of course, the job actually passed. And if you look at what we have here, this job ran for 1 minute and 20 seconds. So let's compare that with the first job that ran, that didn't have the cache created initially, which is this one here. So let's do a comparison. All right. So this first one, which didn't have the cache, right? You can see here, it says, all right, so cache does not exist. So that one took 1 minute and 29 seconds. And this one took 1 minute and 23 seconds. All right. 1 minute and 23, all right, seconds. So, I mean, that's a little bit of a difference. I mean, it wasn't much of a difference, but it's still something anyway. So 1 minute, 29 seconds and 1 minute, 23, all right, seconds. I mean, that's still okay. All right. I just wanted us to see the importance of, having your cache in the pipeline. All right. So let's go ahead and look at the test job. So the test job is also running now. Okay. And let's see. And sometimes too, it depends on the instance you're using to run your jobs, right? So, I mean, if it's a large instance that has a lot of compute, power, it might run faster than, a job, an instance that has, very limited compute power. All right. In our own case, we're using a T3 small, so it doesn't have so much compute power. So we can expect it to not be as fast as possible. But I believe we get the idea of how caching works, all right, in GitLab CI. Okay, so this one also is completed. All right, so let's go ahead and see. The security scan should also run now. Okay, so that has completed as well. All right, so the merge request, all right, the merge request pipeline has completed. All right, which is a good one. All right, so let's merge now and then let's see what happens. The pipeline should not fail this time around. All right, so it failed again. What could be the issue? Let's look at why it failed again. Okay, package job needs Sonar job, but Sonar does not exist in. Oh, I thought I removed the Sonar job from package. Oh my God. Okay, I didn't remove that. You can see that's another error. So we need to basically remove this completely because the job that is trying to depend on does not even exist. All right, in that, main branch. It's not part of the job that will run in the main branch. So that is what is causing, all of that. So let's look at it again so that we don't just, keep going back and forth. All right. All right. So I think we're good now. All right, I think we're good now. I mean, ideally, in a work environment, we won't even merge into main because of the error that we have in the code. All right, we're not even have merged into the main branch because, I mean, there's an error. So we'll have to relate that back to the developers to tell them to check, that error and then fix it, do the merge request event again. If it fails, I mean, we have to keep doing that until, all right, the merge request, the SonarQube scan and the security scan actually pass. And then we can now build the Docker image and, go all right from there. So let's do this for the last time. Hopefully we don't get an error again. So removed Sonar dependencies from the package job. Okay. So let's quickly do this again. So hopefully this time around it doesn't give us an error again. So again, we have to go back to merge request. We have to create another merge request. All right, so that we can trigger this job. I mean, it's part of what you have to do. Sometimes just a simple thing, you have to run it over and over again. All right, so let's create another merge request. That's going to do its thing as well. Hopefully this time around, we won't have to, we're not going to encounter any error again. So let's wait and see what happens. All right, there we go again. We can see that these have completed as well. So let's merge again, and hopefully this time we do not have, any failure. Okay. All right. So the pipeline has been created. So let's see what this pipeline will do. So you can see that in this pipeline, we have just 3 jobs. So we have the package, we have the update M values, we have the trigger, deploy pipeline, right? Now this really is a trigger job, not an actual job as is. So if I click on the package job, that basically should package the application into a Docker image using the Docker file that we already have, and that is expected to update the Helm project that we have to basically help us update the value and all that. So we're going to see that, as soon as this is done. So let's just wait for this Docker build and push thing to complete. Okay, so nice one. We can see that the Docker build and push is completed. So now the next job is to update the Helm project with the latest tag. All right, so that would in turn help. Wow, that was very quick. So you can look at what this did. Okay, of course, the next job will run. I'll show you that. So look at what it did. So here, it basically, switched the branch to this particular branch that was specified, updated the values of YAML with a correct tag, and then, of course, it pushed back to that place. And then, of course, you can see here that it's saying we have to create a merge request, for this. All right. And of course, if you look at the next job, that is what you would call a job that will trigger the downstream, all right, pipeline. So there seems to be a problem. Now look at what this is. This is the upstream job. So the upstream job is the GitOps front-end job. That is the upstream job. Now the downstream job is actually the Helm project. And the purpose of that is that we just want to basically mimic, trying to check if our Helm configuration is valid, if what was updated was okay, and things like that. But there seems to be a challenge because these downstream jobs have been, they are stuck. Because, for example, now if I come back right here, I can see that these are the upstream job, right? The upstream job is the front end, all right, job. That's the upstream job, okay? So we can see that the update Helm value was done completely. The package, which is the Docker job, was done completely. And this right here is basically, these are the downstream job. But if I click on it here, it tells me that, all right, the job is stopped because of one of the following problems. There are no active runners online and no runners for the protected branch, or no runners that match all the job tags. So the job tag that we're using in that project is actually not correct. So if I go over to the Helm job, so let's go to the Helm project. All right, so let's go to the Helm project. So if I go to the Helm project, for example, And of course, you can see that by the virtue of the push that we did, we can already see here that it's asking us to create a merge request. Okay, so we can see that, that trigger actually happened. So these are the trigger here. It's not working because, the runner is not active. Number one, if I come here now to settings and I go to CI/CD, all right, I will see here that the runner that I have, these are the runners, right? This is not available to the project yet. But even if it's available to the project, the tag is actually different. But the first thing we can do here is to enable, all right, this runner for this project to make it available. Now, that does not mean that that runner is going to pick up that job, because the runner is configured to not pick up any job that does not match its tag. All right, that's how the runner is configured. So it's not going to pick up any job that does not match its tags. And these are the tags that we have associated with the runner. All right, so the tag has been associated with the AWS and then Docker tag. So any job that does not match those tags will not run. So what can we do to solve these problems? Okay, because right now the job is stuck. If we come back here, okay, so if we go back to front end, let's go back to front end, just helping us to understand the whole stuff. So if we go back to front end, we can see that that job is running. It's going to run forever, all right? Because here we have the trigger deploy job, and it's trying to trigger a downstream job, but unfortunately the job is pending because there's a problem with the tag, right? So it's not going to pick it up. All right. So even if we update the tags, is it going to work? I don't think it's going to work. But let's just, look at what will happen. So it's basically stuck. So what I can do here is that let me see if I have the Helm stuff opened up. I don't have it opened up, but I can open it up right here. So Helm, where are you? All right. So this is the Helm job. So I can come right here and then open it in my Visual Studio Code. All right. And basically just come right here. This is the pipeline file for it. And here, I basically would just, this is not needed anyway. This path is actually not needed for now. All right, but we can leave that as is. Okay, I basically will have to change the stack. So this will be AWS and then Docker. Okay, and the same thing applies to these as well. AWS, all right, and Docker. Okay. And basically, let's change it for every other thing, AWS and Docker, all right? And of course, this one also, we need to change that, all right? AWS, all right, and Docker, okay? So those are the things that we need to change right here. So I'm just going to come here and say git commit, all right, -am, and then runner tag updated for all jobs, okay? And then we can do a git push again. So that'll push it into the feature branch, all right? Okay, now look at what we have. So it's telling us that there actually is an update. Okay, take a look at that. Now you can see the error we got, because the error we got here is basically telling us that, the front end project has actually made a commit, okay, to the Helm project. So now locally, we are not aware of that update. Okay, so the first thing we need to do is to run git pull. That's the first thing. Okay, because the changes that, the front end project has actually made, we need to make sure that that change is also pulled locally for us. All right. And so, that's the first thing we have to do. So we can write and save those changes. All right, so let's write and save the changes. And so if we have written and saved the changes, and of course we can verify the changes here. So if I come here to values of YAML, I can see now that the front end has been updated. So this tag is A25C3845, right? So if I come here now and I go to this chat, that'll be in the feature branch, because that's the branch that was updated. And then I go to values, you can see that this was updated 6 minutes, all right, ago. And then it says update front end image to what? A256, all right, of course it gives us that information, so that's what we have right here. So that tells you that yes, indeed, it has updated, all right, the stack. So now I can do my git push, okay, again, so git push origin, feature / boutique Helm. Okay, so now the push that I was trying to do can now, all right, proceed as intended. Okay, so you can see that the push now is gone. But of course, like I said, that does not mean that it's going to resolve the error that we have. Basically, we have to cancel, all right, that job. I have to cancel it. So I'm going to say cancel. And unfortunately, that would, not trigger that job because, of that tag issue that we had. But right now, we can actually rerun the job again. Okay, and unfortunately, it will also, now the problem with the trigger is that now it's not going to see that this pipeline actually succeeded. It's going to be seeing it as a cancelled pipeline. Okay, because the downstream job unfortunately did not, all right, complete, successfully as we expected. And you can see that that one is still stuck here, all right, because it was triggered, right? So we have to cancel it from here, all right, as well. And of course, it's going to be seen, it's going to see it as a cancelled job. Okay. So of course, the next thing we can do now is basically to, if you come back here now, it's basically just going to see both of them as, jobs that were cancelled, right? It's not going to see it as a job that succeeded, even though 2 of the stages passed and all that. But because of the tag issue that we had, we had to cancel, all right, the job. And of course, if you look at the arrow you have here, it's basically telling you that there was, a downstream job that was triggered. So lastly, let's try to do, all right, let's try to do some push again so that we can actually just see that in action. All right, of course, we can't deploy to Kubernetes yet because we don't even have a Kubernetes cluster set up yet. So, but I'm just trying to show us the trigger function in GitLab CI/CD. Okay, so let me just put something in the README here, maybe just something to hash, okay, just to commit something. Because if your commit ID, all right, does not change, then that means the values of the YAML is not going to get updated. And of course, it will fail your pipeline because what is expected is that your values of YAML should be updated. For every commit you make, for every change you make, you have a new commit ID, which in turn will help to build a new image. And then the new commit ID will now be the new tag for the image. And by the way, we can actually go to our front end and go and see the image that we pushed, right? So I can come here to deploy, and then I can go to container registry. All right. And then, of course, I can see it right here. So this is the latest tag. And of course, this is the tag that we just pushed. And of course, we look at that. That was pushed 10 minutes ago. Okay. So 10 minutes ago, that was pushed. Okay. And this is the tag that we have here. And of course, the tag is similar to what we saw in the values.yaml. So let's push again and just basically see the trigger in action. Okay. So I'm just going to say git commit. Running pipeline. Again. All right. Tags in project fixed. Okay. All right. The only thing here is that it's going to run those, all the merge request events that we'll have to run again, and then you merge it again and all that. So that's the only thing that we have to just, bear here. But I think it's okay because, it's going to give us an important learning experience. Okay. So it's a good one. So let's quickly do that. Let's do that very quickly. Okay. All right. We can see that the merge request is passed again. So let's merge it back into the main branch. And hopefully this time around, we don't have any errors. Okay. So let's hope that this would go one time without giving us too much of an issue this time around. Okay, so let's see what happens with this now. Now that the Docker image has been built, it didn't take much time because I know we have some layers that have been cached already, so that didn't waste any time. And of course, the M value has been updated as well. We can see that was very quick. Let's take a look at the trigger job now, and let's see how that is doing. All right, so we can see now that the M lint is working. All right, it's been triggered because now we have the correct tag, and it's able to use the runner as well. So let's see. All right, so good, that is working now. Then the Helm package will also work. This is working. All right, we pushed into the Helm, all right, project. And of course, if I come here to the pipeline, I should see, all right, the pipeline as well, right? So we can see that, I mean, the job actually passed. But of course, this is not going to deploy to our Kubernetes cluster because, I mean, it's basically not in the main branch. If it were to be the main branch, we'll still have to even do that manually. All right, but this is basically just to give us, something to mimic that we are trying to perform some validation on the Helm, chart, the values, the YAML, and just basically to check that everything is fine. So we can see now that even from the Helm pipeline, we can see that the job passed, and you can see that this is the upstream job and this is the downstream job. So if the downstream job fails, then the upstream job will also fail. Okay, that's the idea behind the trigger. So this is triggering this. So if the downstream job, which is the Helm project now, if it fails, then the upstream job will fail as well. So we can see how the trigger actually works from one project to another. And of course, we can see the commit history here. Basically, the front-end image has been updated again, with this. So we can see that. So now, if we are okay with what has been done, we can actually now create a merge request into the main branch. All right. So if I click on create a merge request now, all right, it's basically going to merge into the main branch of the Helm project. But that does not mean that, it's going to maybe set up another pipeline, right? I mean, it's not going to create another pipeline because in the main branch, the jobs in the main branch are expected to be triggered manually. Okay. The only thing here is that we've created a merge request, right? We can actually see what, was committed. We can actually see the changes that was made. All right. So here we can verify the changes made. So we can come here to see that, okay, initially the front-end image was this, and then now it is now this particular value. All right. We can see all of that, all of that changes. Okay. We can see that. And of course, even for the tags, we can see that the tags were updated as well. All right. So now we are good to go. So we can come here and see the commit, and then we can see that the image has been updated to 0ADA4. And of course, if we look at the changes, it's a bit different here, but that's okay. All right. So this first one was this one's this one. But from the commit history, we can see here that the correct thing has actually been done. All right. So this is the previous image. You can see that. And then this is now the latest, all right, image. So that is 3 minutes ago. So we can go back to the overview of this one now, and then just do, all right, a merge. All right, and then that will merge that into, all right, the main branch. Of course, it's going to trigger a pipeline, but the pipeline that we triggered is just the lint and the package again, which we can actually remove and not, trigger that again in the main branch. All right, we can remove those two things and then just leave deploy and verify, all right, to be triggered in the main branch. But I hope you get, all right, the idea of what we're trying to do. The Helm project basically contains the Kubernetes manifest files. And of course, we've been able to, template those manifest files into a Helm chart. All right. And then we have the values.yaml and we have the charts.yaml. So what we are doing basically is as we build each of the services and then, push the image to the GitLab container registry, we also want to update the values of the YAML file so that by the time we are deploying to our EKS from the Helm project, right, it basically is using the updated container image from our container, all right, registry. Okay. But before we go on into the other services, I quickly would like to show us how we can leverage AI to template our Kubernetes manifest file so that it can generate for us the values.yaml and, all right, the chart.yaml so that our applications, as we build them, we can also use the pipeline to update the repo, all right, accordingly with the correct image tag and the, the repo, the registry URL, like we've seen with the front end application. So we're going to be using AI to do that. And this is one of the use cases that I believe that you can actually leverage AI to do, which makes it very easy and very quick, all right, for you. Okay. So let's get into, all right, the Helm repo. The Helm repo already exists. As we can see from here, it's something that I've already created. And of course here, I have the Kubernetes manifest files, right? And then, of course, I have another Kubernetes manifest file here. So we're going to be working on this feature branch. I have another manifest file here, which is the manifest final, which basically contains, manifest file for even the ALB ingress and everything that we're going to be doing. So if I click on this one, I can see the full Kubernetes manifest file, which is, of course, in YAML. And we can see, all right, everything right here. So there's the deployment, the metadata, the specifications for the pod, and of course, the container as well. And also here we can see some some specifications there as well. For example, the service account name, the image pool secret, because the image is going to be stored in a private container registry. So we need to specify the image pool secret, the name of the secret that we have created in our Kubernetes cluster. Okay. And that secret basically is going to be the container registry secret. More like when you want to push into your container registry, whether with ECR or with your Docker Hub private or any registry, so the purpose of this image pool secret is to allow you to pull from this private registry. And of course, it's similar to when you have built an image and you want to push an image to a registry. You usually would do something like Docker login, like something like this, which we saw here. Let me quickly see if I can open that up. All right. So which is something similar to this, when you have the Echo CI registry, password, Docker login, and those kind of things. That is exactly what we also have here. So the image pool secret is pretty much the same thing. Okay, but in the case of Kubernetes, what you would use is what you call image pool secret, and this secret is expected to have been created in your Kubernetes cluster. So Kubernetes is going to be using the secret to actually connect to your container registry and pull, all right, the image that you're specified, all right, in this manifest file. So if you look at what we have here, and of course we have some security context here because we don't want the containers to run as root, so we want the container to run, all right, as a non-root user. All right, so we have all those stuff right here, which is actually a very good security best practice. All right. So of course we have the image name here, and of course you can set the tags and then the port and all that. We have all those kind of things right here. So now what I want to show us is basically how we can template this manifest file into a Helm chart, right? Where you have, everything basically, leveraging variables, right? Which means you're not at coding majority of the values are not that coded. You're basically leveraging variables to do that. So you now have a file called values.yaml that contains the value for all of these variables. So what we're going to be doing from the pipeline is to basically use the pipeline to update these values.yaml file. So if I work on the front end project, for example, and then I deploy a new image, I expect that the front end project should also be able to connect to the Helm project. All right, clone that repository, update the values.yaml with the new image tag and image repo URL, and then commit it back. All right, and then of course that will create a merge request like we saw earlier and things like that. So that's exactly what I want. So I want to show us here how you can actually template these. All right. This Kubernetes manifest file and then turn them into Helm charts that you can actually update, independently. And of course, it makes things a bit easy for us. And of course, it makes it easy also in the sense that we can actually deploy with Helm instead of using kubectl apply. We can basically just do M install, upgrade, and M update, and those kind of things. So that in that way, if it is only the front end that we want to update, all we need to do is just to run our Helm update command and all that, and then it basically will just update, just that service alone. And then instead of doing kubectl apply, almost every time. So that's what I want to show us. All right, in this video. So here it's my Helm repo. And so what we want to do is, now I have two Kubernetes manifest file. Now this is the original, manifest file that I got from the Google Cloud repo, and this is the manifest file that has been worked on, that has been structured, to meet what I want. All right, so you have that right here. Okay, so this manifest file now we want to leverage AI to template it, all right, for us. Okay, we want to leverage AI to do that for us, to turn it into a Helm chart and those kind of things. So let's, learn how to use AI to do that. Like I mentioned earlier, we are not offloading everything to AI. We can use AI as an explainer, as a guide, as a help, as an assistant, all right, instead of just prompting AI for almost, every, all right, thing. So, but for this, let's see how we can use AI to achieve this. So here, I'm going to create a new chat. So here, I'm going to create a new chat. All right, so I'm going to come right. And by the way, this is Amazon Q. For if you've not used it before, you can come to the GitLab extension here and then install the Amazon Q extension. Once you install it, you basically would have to sign in with your Amazon Q builder account to activate the Amazon Q. And of course, it's actually free. You can use it, as much as you want. I've not paid for it. All right, so you can, but you need to log in with your Amazon Skill Builder account in order to use these Amazon Q. All right, so, and of course you have some models here. So you have basically two models, the Cloud Sonnet 3.7 and the Cloud Sonnet 4. Those are the two models that you have available for you that you can actually, all right, use. So let's get into this. So let's query Amazon. So here, I'm going to be giving this our AI, some context, so that it basically will understand exactly what we want it to do. Okay, because if you don't give AI enough context, it just generates some random stuff for you. But let's try as much as possible to give it, context and to understand exactly what we want it to do. And of course, it's something similar I want to do. So now the first context is that we already have a folder here that is called the Kubernetes manifest file. Okay, that's the name of the folder. Now this folder already contains our manifest file, and we want Amazon Q to create a folder for us, all right, that would contain the chats. Is that okay? That will contain the chat, okay? And then, of course, in that folder, we now have the values, the YAML, the templates, and, other files as well. So that's the context we want to give it. So I'm going to say, I have this folder in my workspace. Or let's see, I have a Kubernetes -manifest -final folder in my workspace that contains Kubernetes manifest, all right, files. Now I want you to convert that to a Helm chart. Make sure you create a new folder to store the chart and templates derived all right from the Kubernetes manifest final folder. Okay, and then we press enter. Now, the beauty of Amazon Q is that it can actually interact with your current workspace, create folders, edit your files, and do all of those kind of things, all right, for you. All right, it can actually, all right, do that. So you can see here, it's saying, I will help you convert. Of course, it's going to read your context. Okay, so you can see the context here, and then, of course, it has picked up the folder. And then right here, it says, I will help you convert your Kubernetes manifest final folder to a Helm chart. Let me first explore the structure of your workspace and examine the manifest files. So here, it has listed here that we have, of course, one directory, and I can see that you already have a microservice chat folder, all right? But let me examine the Kubernetes manifest final folder to create a new M chart, and let me read a few key files to understand the structure, okay? Now, already you see that we already have we already have one M chat that we are using currently. So it detected that. But of course, it knows that the instruction we gave is we want to create a new, all right, Helm chat. And of course, it has gone through other, manifest file that we have to understand the structure of the manifest file, because that would actually guide how it will template, all right, how it will template the manifest files, all right, for us. Now it says, now I'll create a new mchat structure. I'll create a folder called online boutique chat and convert all the manifest, to M template with proper values extraction. Now here it is asking us the permission to basically create these, all right, folders that are necessary to be created. So I'm going to say run. So that would give the Amazon queue the permission to basically create these folders, all right, for us, and then it will start templating the manifest file and then turning them into Helm chats, all right, for us. And as you can see, the operation is actually ongoing. So it's going to do all of that for us. And the beauty, like I said, is it has the ability to, create files and folders and edit files and folders for you while you just watch it to do what it knows best how to do. So this, I believe, is one of the good use cases of using, all right, AI, because, if we're going to be converting this manifest file into mchat ourselves, it's going to take a lot of time, all right, for us to do, particularly in the case where you have a lot of manifest files, right? Imagine if you have like hundreds or maybe 1,000 microservice application that you want to template into a Helm chat, right? And without AI, it's going to take a lot of time for you to actually achieve that. But if you have AI, you can actually leverage AI to basically do that, and in no time it can do all of that. And if you notice anything that it shouldn't do or that it didn't do well, you can basically just keep chatting with it to point it in the right direction, and that way it saves you a lot of time. All right, it saves you a lot of time. So this is one of the good use cases, in my opinion, of leveraging AI as your assistant, not just rely entirely on AI to do everything, all right, for you. Okay, so it's just my own opinion. I'm not saying that's the way to look at it, but I'm just saying my own opinion is, trust me, it's possible to go through documentation, read things for yourself, understand things for yourself, and then AI can serve as your assistant or as your guide or as your help in breaking down some complex thing, and then in giving you better understanding if you find any confusion in the documentation that you have, all right, read. So you're still converting that. Even with AI, we can see that even the templating is not as fast as we think it will be. So now imagine if I have to do this for each of the services, that's going to take a lot of time. So again, I believe that is one of the good use cases of using, all right, AI to in your work as well. All right, so it looks like it has, done everything that needs to be done. All right, so I think it's getting to the final stage, creating a README file, and then of course creating some notes for us. That's pretty okay. So, it created a README for us as well. So also let me also update values of YAML to include the missing image tags that I noticed from the CAT services. All right. So I think the CAT services uses a Redis cache. Okay. All right, so now it has given us the usage as well. So in order for us to use this Helm chat, we can basically just run Helm install, the name of the chat, and then, all right, we point it to the directory that contains the chat. And then upgrade with custom values. We can do Helm upgrade in the name of the chat, the chat directory, -health, custom values to the YAML. If we have some, values of the YAML file that is not the regular values of the YAML, all right, we can also use that to update the values. And then Helm uninstall online boutique, that will basically uninstall that in from our Kubernetes, all right, cluster. Okay, so these are all the services that have been covered, and we can go back here now and go and see that for ourselves. So we can see here that it has actually created a new folder for us based on the instruction that we give. And then here we can see that we have the values of the YAML. And of course, we can see here that it has extracted those values out. And here we have the global, and then we have the registry. So the registry is this. This is the name of the registry. And of course, we can see my name here because that's the name of the repo. And of course, all the projects are basically inside of that. They are basically inside of that account. And here we have the image pool secret, and of course the name of the secret. So this secret is expected to exist inside of our Kubernetes cluster, but we've not gotten to that point. We'll get there pretty soon. And then, of course, we have all the services. So for the add service, we have the GitHubs-Java code / this. Of course, it's going to be slash, so this is going to be the registry name / all right, what do you call it? / the name of the repo, and then the add service and all those things. And then for the cat service, you pretty much have, all right, the same thing. And then for the email service, you have the same thing for front end, for load generator. You can basically see the value. So this value file is what we're actually using the pipeline, all right, to update. Is that okay? So we're actually using the pipeline to update. And then, of course, we have the ingress here. All right, we have all of that. So we're going to be talking about all these ones as we go on. All right, so don't get worked up about that. So, and of course, if I go back to the template now, I can see all of the template here as well. So if I click on add service, I can see that everything seems to be scattered, right? Because now everything is parameterized, right? So values are not coded. You have parameters, all over the place, okay? So everything seems to be parameterized now. Nothing really is coded here if you look at it. So quite a number of the value is being sourced, all right, from the values.yaml, all right, file. So that is how you can leverage AI to basically generate your stuff for you. Now, another thing you can also do with AI is that, for example, now I can tell, AI to say, what, instead of separating the registry like this, can I have the registry name and the image, name, on one line, and then separate the tags as well. So I can actually come here and say, you know what? Can I have the image contain, all right, the full registry path, and then the tag, all right, separated. Okay, so let's see that. So now it's going to update the registry.yaml to separate the registry path and the tag, and then update the template to use the new structure. So let's see what it's going to do with this information that we have given to it. So let's see what it will do with that. Okay. Okay. All right, so you can already see here that, we can see the changes, right? You can see the changes from my right side here, that it is actually making those corrections that we have suggested, which is a good one. We can see that here already. Okay, so now the template will have to also be updated to use the new structure as well, since we've broken it down. So now you're going to have something like image.repository and then image.tag. Okay, so that's what you're going to have. So image.repository and then image.tag. Okay, so the service, this is the top level, all right, structure. So you're going to have something like service dot the name of the service, and then you're going to have something like image.repository, image.tag, and things, all right, like that. Okay, so the structure has also been updated. So if I click on the value.yaml, I can see the changes that has been made. All right. So here I can see that I still kept these registry here at the top level, but then I can see that there's a change here. So this red means what it deleted, and the green here on the other side here basically means the new thing that has been added based on the new information that we give to this. All right. So we can see that already. So I can see this was generated by Amazon Q. So I can close that, and then I can go back to my values.yaml, and I can see clearly that yes, it has indeed made, all right, that change, and it has indeed done what I want it to do. Okay. And of course, if I feel that this is not necessary again, I can actually go back here and say, do you think, so I can come back here and say, do you think the global dot registry field, all right, is needed, all right, anymore? Okay, so I can query it and say, do you think that is needed? Right? You can see what it says. It says you're absolutely right. Since each service now has the full repository path, including the registry, the global database is no longer needed. Let me remove it and update the templates accordingly. So, it's just basically you knowing that, this is not necessarily, again, why do we still have, the global registry, since we already have that contained in each of the services. That's no longer needed. So you can see here that now it's updating the templates, all right, to basically capture that, so that in case it didn't update the template before, now that we have mentioned it, and of course it says we are right, it would need to do what is necessary. So the update is going on now, and it's going to do that for us. So let's just wait for that to be done. And once that is done, that's just what I want to show us in this video, okay? How to leverage AI to do things like this. This is a cumbersome task, right? Imagine if you have, like I mentioned earlier, hundreds and thousands of, manifest files, and then you want to template that, using Helm. That's going to take a long time, all right, to achieve. So using AI in that case would make more sense, all right, than doing it manually, all right? But of course, like I mentioned, you can also leverage documentation to fact check, to basically, see that what AI is generating is actually in consonance with what you have on the documentation. Is that okay? All right, so that is Amazon Q for us. And of course, with your VS Code as well, you have some other AI you can integrate as well if you want to use it. That's okay. But I just thought to show you this, all right, in this video. So now that you know how to leverage AI to generate your Helm template, I believe we can move on to the other service. And the other service we're going to be looking at is we're going to be looking at the CAT service, because that is written in C#. So we want to see how we can write a pipeline file of what the pipeline looks like, for building a C#, basically a .NET, application. So that's the next thing we're going to be doing in the next video. Thank you so much, and I'll see you on the next one. Bye for now.